Today, we're going to be taking a look at the geometric distribution in Python through a few different examples. We're going to be utilizing libraries of NumPy, SciPy, Matplotlib, as well as Seaborn. And by the end of the video, hopefully you are an expert and understand how a geometric distribution works. But before we do start coding, I want to go over a little bit more background information. All right, so as promised, a little bit more information about the geometric distribution. So the geometric distribution is a probability distribution that models the number of trials required to achieve the first success in a series of independent and identically distributed Bernoulli trials, where each trial has two possible outcomes, success or failure. That sounds kind of complicated, but let's break down these examples and you'll understand how this works. So the first one is text X number of items until a defective item is found. So let's say you're Tesla and you're taking a look at the Cybertruck assembly line. Let's say every 25 items on average is going to be defective. So you'd be taking a look at a geometric distribution of that. Number two is number of views needed for a new subscriber from a video. So let's say on average, 10% of my views become a subscriber. So let's say it takes every 10 views in a video to gain a new sub. The second example, number of views needed for a new subscriber from a video. So let's say, for example, 2% of views turn into subscribers, which means about every 50 views will be a new sub from a video. So we'd be taking a look at something like that for the geometric distribution, right? Someone watches the video, did they subscribe or did they not subscribe? And we'd keep going until we figured out. And number three is coins flipped until tails. So you're flipping a coin, right? Let's say first time heads, second time heads, and then third time is tails. So we'll be taking a look at the geometric distribution, right? You have a success or failure, which would be your heads or tails. Now, the geometric distribution is going to be discrete because it'll tell you the number of trials until something essentially happens, right? We find the defective part, we get someone that subscribes to a video, or we get the tails. So a few terms that you need to know before we jump into our code. Those would be the PMF, which is probability mass function, and the CDF, the cumulative distribution function. By the time I'm recording this video, I should have both on the channel. If not, I will have them a little bit in the future. So you can think of PMF would be like an exact probability of success. And then CDF, you can think of this as the probability occurs within the first K amount of trials. Now we're going to be building out actually a few different graphs. So we'll be building out the PMF of, first we're going to build out this histogram, and then we're going to be building out the PMF, right? Which would make sense if our frequency is higher. Same would be our probability. And lastly, we're going to be taking a look at the CDF. So with this background information out of the way, I think we are ready to code. All right, so let's start off by bringing in all of our imports. So import NumPy as NP from SciPy.stats, import geom, import matplotlib.pyplot as plt, import seaborn as SNS. So once those are there, then what we need to do is set up a random seed. So np.random.seed, and then pass in a number. I'm going to pass in 17, so that way you guys can duplicate this code as needed. And yeah, let's take a look at our first example. Well, this is going to be the example we're going to be looking at for this video. So one of my hobbies is I collect cards. So Topps has the odds of pulling cards out of packs. Apparently they have like a virtual queue or something like this right now. Oh man. I would show you guys what this looks like. This is annoying. So I'm gonna pause the video, and once I'm into the website, well, you know, they must be releasing a product right now. All right, so I loaded up all the different odds over here. You can see the specific type of card, and you can see the product associated with it. There's a ton of data based around it, but regardless, what I want to take a look at is pulling a rookie autograph. Now, I can choose whatever box I want, right? You can see MLB Topps Chrome Monster boxes 1 out of 81, Topps Chrome 2024 Hobby 1 out of 43 packs. But what I'm really going to take a look at is this MLB Topps Chrome Hobby Jumbo 1 out of 8. Now, this makes it pretty easy, right? Because 1 divided by 8, you're going to have 0.125. And if you put that in percentage, 12.5%. So I thought that was going to be easy for the tutorial. This is what we're going to be basing it around the odds of pulling an autograph card or a rookie autograph, right? No parallels or anything like that. And 1 out of 8 packs. So let's take a look at the geometric distribution behind this. Okay, so let's start with part 1 over here. Now you guys are familiar with the odds. So we'll say example 1, 1,000 random samples with NumPy. Okay, and first thing we're going to do is set our probability. So P equals 0.125, since you can pull an autograph every 8 packs. So we have that over there. Then we're going to say samples equals np.random.geometric. And then pass in your value of P and then the size, which you could have defined it outside. I've done that in a few videos, but you can also pass it in right over here. So probability 0.125, 1,000 samples. This is going to be randomized based off of seed of 17. And yeah, so let's print out these samples, what these take a look like. So print out our samples, and you can see how many packs it takes to pull an autograph. 3, 6, 2, 1, 12, 8. It goes all the way down over here. I'm not going to go through every single one of these, but yeah, let's take a look at some basic calculations behind this. So we'll say it's example 2. So example 2, calc mean, var, and standard deviation. And the way we can do that is np.mean, pass in our samples. We should have pretty close to 8. You can see 7.924. And let's go next. We can take a look at our variance. So np.var, pass in our samples. And this is all basic stuff I've covered in other videos already. But regardless, throwing in here if this is your first video of mine that you've checked out. And yeah, so np.std, right? And we grab these 3 data points and 33 lines of code. Why not grab it? And you can see our standard deviation, right? Square root of variance is 7.349. Okay, so next few examples, we're going to plot out some stuff. Plot out a histogram, then PMF and CDF. Let's do that. Example 3 is going to be our histogram. And we'll be using matplotlib for this. So you can set your fig size if you want. Just plt.figure. I'm going to start off with plt.hist over here, pass in our samples. Then bins equals np.arrange. I'm going to go 1 to 53. The reason why, if I remember correctly looking at this data, and this was, I built out my example code a while ago. I think like 52 or something like that was the highest number. So that's why I went through 53. We'll do minus 0.5. Then edge color equals black, and our width equals 0.8. Then what I'm going to do is I'll set my X label and Y label. So plt.xlabel, and I'll literally just copy that and change it to my Y label. And we'll also have a title. That. We're going to have X ticks as well as grid. So I'll just change those. X ticks, grid, and then at the very end, show. So do that. That way I don't have to keep typing PLT and everything like that. Okay. X label is going to be packs open. Our Y label over here is going to be frequency. Title is going to be histogram of geo data. Okay, X ticks over here. We'll use this np arrange. This grid over here will have axis equals y, axis equals y. Set our line style equals 2 dashes, and then alpha equals 0.7, and then show. And we should have this, assuming no errors. Yeah, you can see we have one right over here. Honestly, I'm going to change my fig size. I skipped that line. I didn't think it was necessary, but apparently I needed that. So I'll just go over here, plt.figure, and fig size equals 12 to 6. I forgot there's technically a ton of values on the x-axis, so I needed space when I first wrote it out. And yeah, 51, the highest, way over here. Huge outlier, but you can see 1 is the most common. All right, so to explain this in pretty easy terms, with each additional trial without success, the likelihood of success in the specific trial decreases. It's more common to get a success early here in the beginning than it is later down the road. And yeah, so you'll see this also with our PMF, which I'm going to do next, I believe. Yeah, so example 4 is going to be our PMF. So example 4 PMF. So how we're going to start this, we'll say x equals np.arrange, go 1, max samples plus 1. Again, Python. Well, I didn't talk about in this video, but you want to have one extra one just based off of how Python ends with arrange. And then let's set up our PMF. So PMF equals geom.pmf, pass in our x values, and then pass in our probability of p. Have all of these over here, and then we can plot a histogram again, but this is going to be our PMF. So let's have all these. All right, figure, I'm good with that. Over here, samples bins equals np.arrange. This is going to change a little bit, so let me just make these modifications. We'll have 0.5, 0.5 max samples plus 1.5. Then over here, we'll have density equals true. For alpha equals 0.6. Color equals green. G over there. And then also have edge color equals black. We don't have our width on this one. Okay. And then let's just set all these over here. Grid, I'm just going to say is true. This one. X label. Right, we'll have our packs opened. Then we'll have over here on this Y label the probability. It's a frequency, probability. And then our title over here, histogram of PMF geodata. There we go. You can take a look at what this looks like over here. Honestly, I don't love this graph. I'm just going to copy what I had for my sample code. Something's off. There we go. I think it was with the fig size, but regardless, samples, bins equals NP arrange, density true, alpha 0.6, color green. Yeah, I think it was just because I had my fig size and it just made this different in comparison. But regardless, right, as what's shown over here on our basic histogram, PMF, very similar, right? Our probability increases. You can see that we have 0.125, right? Which is the 1 out of 8. And then it decreases over time as the number of trials. I initially thought that 51 is actually the greatest. And you can see there's one way over here past 60 and somewhere in here. But yeah, that's our PMF, the probability for each of these specific trials, right? 0.125, it decreases over there. And let's take a look at our CDF, which is a cumulative function. So it'll start at 0.125, then we'll add in this one, we'll add in this one, keep expanding out. So let's go over that. And I will have full videos on the channel with PMF and CDF and all this. So if it doesn't click the first time, no big deal. Just check out another video and it'll eventually click. So let's set up our CDF. We'll say CDF equals geom.cdf, pass in X, pass in P, right? And this is what we already have over here. Our X is all for samples. And then P is our probability that we set way in the beginning, right? The 0.125. Okay, and now what we're going to do, we're going to copy this histogram code, but we're going to turn this into a step. So instead of histogram, we'll turn this into a step over here. And what we'll do was pass in X over there. I'm gonna remove a lot of this because we don't need it. So we have X, then we have our CDF, then where equals posts, and then color we'll set as blue, like that. And set our title, we'll say CDF of geometric, and then number of trials, and we'll say cumulative. We can show our grid. And check this out. So when we start at 0, right, or start at 1, we're at like 0.125, and then we scale up again, right? And each of these steps are these PMFs. So 0.12, then we add in this one. So we're probably over 0.2, right? 2, and let's check that out, right? So around like 4-ish. 1, 2, 3, 4. Does that make sense, right? We're a little bit above 0.8. Let's say these are like, we'll just say these are 0.08, right? 0.16. Then we have this, which is 125. So that's 0.28. And then over here. So that makes sense, right? Why the cumulative. So you keep adding each of these PMFs, and it's cumulative over time for this geometric distribution, right? At the very end, let's say you open up 60 packs of baseball cards. You should have pulled that autograph by then. Really weird if you did not. So again, let's just kind of recap the code over here. So example 1, right? We generated 1,000 random samples. NumPy, I said the probability was 0.125 of pulling an autograph in any pack, right? And grab that from that sheet. I generated samples equals NP random geometric, probability in 1,000. And we printed out all these samples over here. A few lines of code, you can find your mean, variance, and your standard deviation. Then I showed you how we can build out a histogram of our geometric data that we generated right over here, right? Pretty easy across the board. Then down below, I showed you the PMF, right? The probability of any of these, and it makes sense, right? Our first one is going to be 0.125 or 12.5% because that 1 out of 8 pack odds, and it decreases over time, right? Because we're expected to pull our autograph pretty early on. Then we have our CDF example, which is the cumulative distribution function. So think about this, if this makes sense or not, right? We're going to keep scaling this up. Okay. Our first one over here is 0.125, right? And our second one over here, well, let's say it's like 0.22, like eventually we get over 0.4 across the board for the number of trials. Hey, I hope you guys enjoyed this video on the geometric distribution. If you're new here and you want to help support the channel, make sure to subscribe. It's 100% for free. And one of our goals is to achieve 100,000 subscribers in 2025. And the only way to do that is by uploading at least 3 data science focused videos every single week. Now, if you want to learn even more about statistics and how we can use it in Python, I have 3 videos linked down below in the description, and I'll put a video right over here for you to check out.